So these are the last 4 slides that I did not get to in the review sessions that we had this week. So I wanted to do a short video to go through these. The first one here, I would say on each of these, try them first before you listen to me. But on the first one, you're asked to construct a 95% confidence interval estimate for the proportion. So that's important there. It's a confidence interval for the proportion. So on these confidence intervals, really let the formulas guide you. So the formula for a proportion type confidence interval is going to be using the margin of error, which is z alpha over 2 times the square root of p hat q hat over n. So I need to know a critical value. I need to know my p hat, my q hat, and my n. So looking at this, I have a sample size of 1,032. They were asked what they missed most when electrical power was lost. Of the respondent, 134 indicated their computer and or internet access. So that was my X. So when I look at this, I want to do a 95% confidence interval of the proportion. Okay, so because it is a 95% confidence interval and I'm needing a Z, then I can go to those memorized values. So for 95%, the Z is 1.96. Okay, so I need my P hat. My P hat is 134 over 1,032. So when I divide that out, I get 0.1298. I would carry that several decimal places. Or if you want to keep it as a fraction, that's fine as well. Okay, and then my n with q, by the way, is 1 minus q hat's 1 minus p hat. So do 1 minus this value and you get this. And so then we have 1,032 for my margin of error. So my margin of error is 0.0205. So to actually form my confidence interval, I'll do p hat minus the margin of error and then p hat plus that. So I'll have 0.1298 minus 0.0205, and this should be a p, not a mu. And then 0.1298 plus 0.0205. So my endpoints on this would be 0.1093 and 0.1503. Okay, so and then round appropriately for that based on whatever your directions are telling you to do. Okay, so here we have our confidence interval with that. If I wanted to check this, what I could do is 1 proportion Z interval and let the calculator check that for you. But be careful in the directions, especially on the free response part of the exam. If it says show your work, show your calculations, then I'm expecting to see this. If you just write down answers, you're not going to get full credit for it. Okay, the next one here, use a 0.05 significance level to test the claim that there is no significant difference between the heights of mothers and the heights of their daughters. So these are paired up. It's a mother and a daughter. So these go together. So this is going to be the matched pairs kind, or it's going to be the 2 sample mean dependent. So they depend on each other. Okay, so to do this one, you're going to have to put the mothers in L1 and the daughters in L2. And then L3, you're going to have to do L1 minus L2. Okay, so most of this is going to be done in the calculator. Okay, so we're doing L1 minus L2. So we're really just looking at the difference between these two data sets. Okay, so to set this one up, I don't really have a lot of values to identify because most of them are just simply in the calculator itself. So when I set this up, it's because we're talking about the difference. It's going to be the mean of the difference is equal to 0. And then here it says there is no significant difference. So there's no indication of one being greater or less than. So this would be a does not equal to 0. This is my claim statement, because that's indicating there is no difference. Okay, so when I put this in my calculator, I'm going to use a t-test, and I'm going to do the t-test for L3. So make sure that you're doing a t-test for L3. When I do that, my test statistic is going to be t equals 0.283. My p-value is 0.783. So my statistical conclusion, because my p-value is larger than my stated alpha value here, I'm going to fail to reject the null hypothesis. And then for my non-technical conclusion, because I failed to reject the null hypothesis, I would say there is not sufficient evidence to warrant rejection of the claim. So remember, I said that on these statements, I will be giving you the statements to pick. You're not going to be writing them, but you do need to be able to pick the correct one. So as long as your claim is in the null, you're going to have to say something about whether you can reject the claim or not. If the claim is in the alternative, that's when you can say something about supporting the. Okay, the last one here we've got is a actually not the last one. I have one after this. We've got two different data sets here. We've got a before and after. So if we were to be performing a hypothesis test, then we would be doing a matched pairs hypothesis test. But this is not a hypothesis test. This is looking for linear correlation. So the first thing we want to do is to complete a scatter plot. So scatter plot on this, you're going to go to second equals and make sure you've turned on the graph, and you're going to choose the first graph. And in that first graph, you're going to you're going to do zoom number 9 to get a good window. So you're going to end up with a graph that looks something like, okay, so determine the linear correlation coefficient. You're going to go to stat, test, go all the way down to linreg t-test, and you're going to choose to do that. Okay, so when you do your linreg t-test, you are going to get an R value that is 0.965. As far as setting up the null and alternative hypothesis, these are the same every time you check for linear correlation. It's going to be rho equals 0 and rho does not equal 0. The null is indicating no correlation, and the alternative indicates that there is a linear correlation. All right, so we want to determine the p-value. The p-value, again, we're going to get from this linreg t-test, and that's going to be 0.000106. So determine if a linear correlation exists. Regardless, we don't really have an alpha given here. We'll just assume 0.05. That's a fairly common one. So at a 0.05 significance level, our p-value is definitely less than that. It would be less than any of the common ones that we would be using. So if that's the case, then we're going to say that we're going to reject their null hypothesis. If we reject that null hypothesis, then we're going to be able to say that a linear correlation exists. So find our regression equation. That's going to be, again, from this linreg t-test. You're going to find the A and the B. So my A is going to be 20.447, and my B is 0.868. So this is my equation. Part number 7, predict the weight after using the diet if the before weight is 180 pounds. Okay, so we're going, because it is a linear correlation does exist, then we're able to use the regression equation to make a prediction. So I'm going to put the 180 into this, and I'm going to come down here to do that. And so I'll have y equals 20.447 plus 0.868 times 180. And my value when I plug that in is going to be 176.687. So that's going to be my answer there. And then number 8, this is actually a typo here. It should just, number 8 all runs together. If there was not a linear correlation established, what would be the predicted value for someone weighing 180 pounds? So let's say we don't have a linear correlation that we've established. If we don't have a linear correlation, we cannot use our regression equation and make predictions. What we have to do is we actually have to just look at averaging our y's. So we're going to come up here. These are our x's. These are our y's. So we're going to average these together. And if I average those or find the mean of those, then what I'm going to find is that the mean is going to be 176.125. So that would be what I would report if I had not established a linear correlation. But since I did establish a linear correlation, the best prediction is my regression equation. So just be careful that you can't just automatically blindly plug into a regression equation. You have to have established that a linear correlation exists first. Okay, so this is the last one here. So in a simple random sample of 40 Chips Ahoy reduced fat cookies, it's found that the mean number of chocolate chips per cookie is 19.6 and the standard deviation is 3.8 chocolate chips. Use a 0.05 significance level to test the claim that the Chips Ahoy reduced fat cookies have less fat because they have a mean number of chocolate chips that is less than the mean of 24 for regular Chips Ahoy cookies. Okay, so looking at this, what we have here, so we have a random sample of 40 Chips Ahoy reduced fat cookies. The mean number of cookies chocolate chips per cookie is 19.6 and the standard deviation is 3.8. And again, both of these values are referring back to those 40 that are being studied. So they're not for chocolate chip cookies in general. They are for those specific 40 that are being studied there. So, so looking at that, we've got an alpha of 0.05, and we want to test the claim that the Chips Ahoy reduced fat cookies have less fat than the mean of 24 for regular Chips Ahoy cookies. So I'm not so much comparing it to two different samples as I am to the value of 24. So this is actually one of those first hypothesis tests that we looked at. So my mean is going to be, I'm going to be comparing that to 24. And the alternative is that they have less than that because they're reduced fat. Okay, so this would be a t-test if I was going to do on the calculator. If I was asked to show my work for my test statistic, I would do t equals x bar minus mu divided by s over the square root of n. So I'm going to have on this, my x bar was 19.6, my mu was 24, my s was 3.8, and my n was 40. Okay, so when I do that calculation there, I get negative 7.323. Okay, my p-value, I've got my test statistic here. I'm looking at a left-tailed test, so I'm going to do a t-CDF from negative infinity to negative 7.323, and it has 39 degrees of freedom. If you put this in your calculator, you get a very small p-value. Okay, so this is my p-value. When I compare it to my alpha, it's going to be less than that, so I'm going to reject the null hypothesis. So this was my claim here, so I'm going to reject the null, and so I'm able to support the claim. So there is sufficient evidence to support the. Okay, and so that's the last one that I had as part of the review presentation. So, so definitely take a look at all the resources under the exam review and let me know if you have any questions.